Okay, so here we're going to have a look at just the parabola and how to deal with it. A couple of important points. G of x is equal to mx plus c, and f of x is equal to a squared plus b. These are obviously the general equations. We are going to have to find the specific equations. So just a couple of interesting points. This a value, d value, all of this information can be seen on the graph A, D, B, C, and E. Those are very important points. They're not just random. These are two x-intercepts. That is a y-intercept. E is a y-intercept and the turning point. And C is the point where the two functions intersect each other. So what we're going to have a look at now, we're going to answer some of the questions. Okay, so these are some of the questions we are going to try and answer. So clearly here we can see that we need to determine values for m, c, a, and b, which are the unknown variables in our parabola and in our straight line. So look, here is my function. We know it needs to be at the point y equal a x plus b. Very easy. What we want to do here is we want to substitute some of the points, or any other points that we can. Clearly here we can see b is 2, so that is one of the important points that we need. So this b value over here, I'm going to substitute in there because that is my y-intercept. So what I will end up with is y equal to a x plus 2. And then from there, I still need to solve for a, and the only way we solve for a is by substituting one other point that we know, and so we do know that a value. And so how we do it, we're going to substitute in the point -1 and 0. So that will be 0 is equal to a minus 1 plus 2. Solve for a, I get 0 is equal to minus a plus 2. Minus 2 is equal to a, negative a in this case. So therefore 2 is equal to a. So my function is therefore y equal to 2x plus 2. Relatively simple. We're going to do the same thing for the parabola. So if we have a look here, my parabola is y is equal to ax squared plus b, or plus c. And in this case, we know that the turning point is going to be that value, and we're going to substitute one extra value. So this is going to be y is equal to ax squared plus 5, and I'm going to substitute that point again because it lies on both of them, so it's the -1 and the 0. So we end up with 0 is equal to a minus 1 squared plus 5, minus 5 is equal to a, and so there we go. And we know that should work because it's a negative a value, which means it's a sad face graph, and clearly we can see that this here is a sad face graph. So my function is then, oh, wrong colors, y is equal to minus 5 x squared plus 5. Right, so that's how finding the equation works from the function. Right, so now we're going to attempt to answer some of the questions. So what we're going to try and answer now, we've already found our m value, our c value, our a value, and our b value. That is here, the -5, the +5, the 2, and the +2. Now we're going to look to determine the coordinates of C. Now anytime we're looking for a point of intersection, which is this point over here, we're always going to make f of x, let's just go back, always going to make f of x equal to g of x. Anytime we're trying to find the intersection of two lines, we're going to make the two lines equal to each other and solve. So we have 2x plus 2 equal to minus 5. Let's just clean that up. So we're going to have 2x plus 2 equal to minus 5x squared plus 5. Now, to solve that, so after a little bit of factorization, moving the x squared over, we end up with 5x squared, 2 stays there, 5 comes over, it becomes negative 3. Factorize that trinomial, we get that, and so our answers are x equal to 3 over 5 and x equal to negative 1. We can see that this negative 1 already is in play. Here it is over here. That's the first point of intersection. This is then the other point of intersection. And if we look, this is negative 1, this is positive 1 because they are symmetrical about this y-axis. And the c value looks like it's inside of the 1. So it should be a fraction. So there we have it there. That is my point C. That is the x value. Now in order to find the y value, I have to take this value here and plug it back into one of my equations, and so I get y is equal to 2 times 3 over 5 plus 2, and when you solve that you get, so what you get roughly, y is equal to that. When you do the operation you get 16 over 5, which is roughly 3.2. And so if we take a bit of a closer look at our stuff, we will see that this is just above 3, so it could be 3.2, and that's just below the 1, so it could be 3 over 5. So that is how we answer this point B. There is a work solution that will be provided at the end of this for you guys to see, but this is just some of the worked example. So let's have a look at the next question. What is the length of EB? So now we're going to have a look at the length of EB. If we look closely, we can see that the distance between these points, if that is at 5 and that is at 2, that is what we're looking for, that little area there. And so it's pretty simple. We just see that at E, the y value is 5, and at B, the y value is 2, so the distance EB is 3, right? Or 3 units if you want. Next question says, what is the axis of symmetry for F? And if we look at F, F is our parabola, and always, if your turning point is on the y-axis, your axis of symmetry is always going to be x equal to 0, because it is symmetrical about that line. The next question, determine the equation of H, the straight line that is perpendicular to G. So we already know from our previous slides that G of x is equal to 2x plus 2. Now what we've got to remember, in order to find this information, there's a key point here, which is this word here. Perpendicular means that it has the inverse gradient and it must pass through the point D. So that is the point that we've got to substitute in to solve. So the first thing we're going to do, we're going to just flip this fraction of my gradient, so it becomes a half, negative a half, x plus c. So this is going to be h. And all we do now is we substitute in the point D, and we know that D is the point 1 and 0 because it is symmetrical about that point. And so we take our 0 equal to 1, we'll put it there. We'll leave the negative a half in front, plus c. And so we get 0 is equal to negative a half plus c. So a half is equal to c. So therefore, my equation of h is just h of x equal to negative a half, because that's the perpendicular part, and we're going to say plus a half because that is then going to allow us to pass through the point D. And last but not least, determine the points where H intersects with G and with F. So that's quite a big question, right? Because now we've got some sort of a graph or a straight line. We're not 100% sure, but we know it's going to go through the point D, something like that. And so there's going to be a point of intersection somewhere over there, somewhere over there. We already know that is the one point with the parabola. So we are wanting to find determine the points where h of x intersects with g and f. So that would be that point and probably that point over there. So how we do that is to make two equations, one where h of x is equal to g of x, and one where h of x is equal to f of x. Those are the same processes, just equating the two different graphs. So what we will do is we'll just add a blank page here. We will just take this equation and we will equate it to negative a half x plus a half. So those are my two equations. I end up this side with 2.5 x is equal to a half minus that is negative 1.5, and so x is equal to negative 3/5. We still obviously need to find the y value, so the y value will be any of those, so it's 2 negative 3/5 plus 2 is equal to our y value. So that will give us y is equal to, you can plug this straight in your calculator if it makes it easier, and so we have the 1 point being negative 3/5 and 4/5. So that is the 1 point of the intersection between the two straight lines, which are roughly looking something like that with my axes over there, and they are intersecting at some point. Now to find the equation of, so now what we're going to look for is we're going to look for the intersection between the parabola and our straight line f. So first thing is first, move everything over. Because it's a quadratic, I'm going to have 5x squared minus a half x plus a half negative 5. And so if we simplify this out, we get so that's kind of a difficult one to factorize, but if we do it on a calculator, it can be quite easy. So an easy way to sort this out, because the problem is having to deal with these halves here is quite difficult. So if what we do is we just rewrite this to be 0 is equal to 5x squared minus a half, or minus 4 times 2 is 8, 8 plus 1 is 9/2, And what we can do is we can just multiply all of these by 2 so that we get rid of the denominator, and we end up with 0 is equal to 10x squared minus x minus 9. That is slightly easier for us to solve, and so when we put it into when we solve it, what we get is 10x plus 9 and x negative 1. We already know the negative 1 works, or the positive 1, so therefore x is equal to 1, or x is equal to negative 9 over 10. Right, from here, if you flip back a couple of pages, you'll see that the graph we've already used that point. So what we will do is we'll use this point and we'll substitute this back into our equation, and we get into either one. Maybe this one is a little bit easier. 9 over 10 plus a half, and that should give us 19 over 20. And so if we move this up slightly, let's just move that, we end up with the coordinate minus 9 over 10 and negative 9 over 10 and 19 over 20. These seem like complex numbers, but they're really not. If you follow the process all the way down, you shouldn't have an issue, even if these are ugly fractions. So just on this page here again, you can see that, just for some interest's sake, here's the question again. There was my parabola. Here was a straight line with our key points over here, A, B, C, and E. Basic finding the equation question. Determine the coordinates of C is a basic point of intersection of two functions question. The length of EB, a little bit of a graph deduction. Axis of symmetry you need to know for the different functions. Determine the equation. This is a little bit more deductions, or a little bit of the next level sort of kind of question where we transforming some sort of a function. And the last one is then a repeat of this coordinate of C, but with our new function and with the two functions, so it's a repeated kind of question. On the next page you will see just the final answers in a bit more of a neater version for your viewing.